right, this video is for section 5.2 in Algebra 1. It's all about solving absolute value equations. And the first part of this lesson is going to be a review. I think you would have done this back in Algebra 1. Okay, so even earlier this year, we talked about absolute value and the idea that when you take the absolute value of something, it just makes it positive. So the absolute value of 3 is 3. The absolute value of negative 3 is still 3. So it doesn't matter what's on the inside, positive or negative. When you take the absolute value, it becomes positive. So if I say I have the absolute value of x, so the absolute value of some number is 3, then based on what we said above, that number on the inside, that x might have been a positive 3, but that number on the inside, that x might have been a negative 3. Because of the fact when you take the absolute value, you're going to have it's going to become positive. So with that same thing in mind, if the absolute value of some number, we're calling it x, is 5, then that number on the inside might have been positive 5, or that number on the inside might have been negative 5, and hopefully now it's starting to look a little redundant. If the absolute value of some number is 300, then that number on the inside might have been 300, or it might have been negative 300. So really, what I've done, this was an equation that had an absolute value in it, an equation that had an absolute value in it, an equation that had an absolute value in it, and notice when we solved those equations, we had two solutions. Okay, so look at the box. You know, if it's in a box, that means it's important. When solving absolute value equations, you should always write two equations. Because if you want two solutions, you have to have two equations. Now, we are going to put a qualifier in there. Note, you don't want to write your two equations until you get the absolute value by itself first. So first, isolate the absolute value. Meaning get the absolute value by itself. Okay, so let's try an example. When I look at my first equation here, number 1, do you see that the absolute value is already by itself? It's already over on the one side by itself. There's nothing else there. So now I'm going to write two equations. So based on what we talked about above, I'm going to say either the stuff underneath, either x minus 5 comes out to be positive 7, or the stuff underneath, the x minus 5, comes out to be negative 7, because then when we take the absolute value, they would turn positive anyway. So that's how we write our two equations, and then we just solve each one of those separately. In this case, if I solve and add 5, I would get x equals 12. In this case, if I add 5, I would get x equals negative 2. So there are my two solutions to the absolute value equation. Okay, let's try another one. In this case, on number 2, do you see that the absolute value is not by itself because of that 5 right there? So the first thing I have to do is get rid of that 5. Since that 5 is being multiplied by the absolute value, I'm going to divide both sides by 5. So I've got absolute value, so those cancel, absolute value of 5x minus 10 equals 9. So first I get the absolute value by itself. Now I can go over here and write my two equations. Either the stuff underneath, the 5x minus 10 equals positive 9, or the stuff underneath, the 5x minus 10 equals negative 9. And now that I have two equations, I can solve each one separately. So add 10 and divide by 5. Same thing over here. Solve, add 10, and divide by 5. So again, I have two solutions to my absolute value equation. Okay, look at number 3. Before I can write my two equations, I have to get the absolute value by itself. So in this case, first I'm going to add 9, and then I can go in and divide by 2. So when I add 9, I'm going to have 2 times the absolute value equals 4. And then when I divide by 2, that's going to get rid of the 2 on the left. So all I have is absolute value of 4x plus 11. And if I divide the right side by 2, I'm just going to have 2. Now that the absolute value is by itself, I can write my two equations. So either the stuff underneath, the 4x plus 11 equals positive 2, or the 4x plus 11 equals negative 2. And then I solve each one separately. So subtract 11 and divide by 4. Over here, subtract 11 and divide by 4. Two solutions. Okay. I don't know, on the next page, I don't know why we have this here. It's just kind of a repeat. Okay. Oh, no, it's not. I'm sorry. Sorry about that. If the absolute value of x equals -4, then x equals what? Well, hopefully what you're noticing is the absolute value can never equal a negative, right? It doesn't happen. So that since it can't happen, what would we say the solution is? We would say no solution. So if you ever notice from the beginning that an absolute value already by itself equals a negative, you don't need to write two equations because there's automatically no solution. So when I look at number 5, right now, that's not the scenario. I don't have absolute value equals a negative, but I also don't have the absolute value by itself yet. So if I subtract 10, which is what I would always do first, I'm going to say absolute value of 3x minus 2 equals, hey, when I subtract 10, I have -5. Now, do you see that we have an absolute value equals a negative? Now we can say no solution. No need to even write my two equations. Okay, so when I look at number 6, when I first look at it, it doesn't look, I don't have an absolute value equal a negative, so I have to start working it out as if it's going to work. So the first thing I would do is subtract 10, so -3, keep the absolute value of x minus 2. When I subtract 10, I have +5. All right, I can't say no solution because first of all, I don't have the absolute value by itself yet, right? In order to get the absolute value by itself, I'm going to have to divide both sides by -3, and they cancel on the left, so I have absolute value of x minus 2. And do you see now on the right side, I have a -5/3. And since there's no way absolute value can equal negative, now we can say no solution. So I'm just trying to point out that it might be that at the beginning, it doesn't look like you have an absolute value equals a negative. On the first one, it equaled +5. On the second one, it equaled +15. But you got to wait until you get the absolute value by itself to see if there's a negative on the other side. Okay, look at number 7. So start by subtracting 15. So absolute value of x plus 2. If I subtract 15, I get 0. Well, that's not negative, but it's also not a positive number. Can the absolute value equal 0? Sure it can. And so you might say to yourself, well, do I have to write two equations? Well, think about it. If you followed the same pattern, you would say either the stuff underneath equals +0, or the stuff underneath equals -0. But isn't -0 the same as +0? So if it equals 0, you don't really have to write two equations because it means the same thing. But you can still solve for x. So this is the only scenario where an absolute value would only have one solution. In this case, x can equal -2. Okay, so just to finish this out, number 8, you might say, oh, look, it equals 0. Yes, but we're not done. We don't have absolute value by itself. So start by subtracting that 2. So absolute value of 3x minus 2 equals -2. Oh, now we're going to say no solution. Okay, so I would say all of the first page, oh no, maybe not. Really probably the only part that you've actually seen before is this very first part up here at the top. So down here, this part is, this solving absolute value is probably new for you. And then this is kind of the weird stuff that can happen. And then there's a next level, which a lot of times we do it on the second day. So just keep that in mind. One's where you have fractions, but I'm going to go ahead and show you on this video. So it's ugly because there's a fraction in it, but it's still just an absolute value problem. So I'm still going to follow the same pattern. The absolute value is by itself, so I'm going to write two equations. Either, whoops, sorry about that. Either x over 3 plus 2 equals +7, or x over 3 plus 2 equals negative 7. But one thing that we might do now is, remember we talked about way back when, if there's a fraction involved and you don't want to have to deal with fractions, what you could do if you want to is from the very beginning, you could multiply everything through by that common denominator, which in this case is 3. And if I multiply everything through by 3, well, 3 times the first term is just going to cancel that 3. And so all I have is x, and then 3 times 2, and then 3 times 7. So really this is the equation I'm solving. And if I subtract 6, x equals 15. Okay, and again on this one, if you want to, from the very beginning, you could multiply all the way through by 3. If I multiply 3 by the x over 3, right, they cancel, and so I just have an x. If I multiply 3 by the 2 plus 6, and this time it's going to be equals negative 21, so that when I subtract 6, I'm going to get negative 27. So keep in mind, if there's a fraction, it might be easier to just from the very beginning multiply all the way through by the common denominator, and so you don't have to deal with fractions really. Let's try one more with fractions here. Look at number 10. So the absolute value is already by itself, so I'm going to start by writing my two equations. I'm going to say x plus 2 over 3 equals 7, or x plus 2 over 3 equals negative 7. Now, it seems almost exactly the same, but the difference is, in the first case, it was only the x that was being divided by 3, but now it's the whole thing. So that, again, when I multiply all the way through by 3, these 3's cancel, so on the left, all I have is x plus 2, but you still have to multiply the other side by 3 and get your 21. So in this case, x equals 19. And again, do the same thing. Multiply all the way through by 3, so it cancels. So x plus 2 equals negative 21. And then if you subtract 2, x equals negative 23. So again, we're still writing two equations. It's just that we're doing some practice on some of the uglier solving. So let's just do one more. Look at number 11. Remember, we always start by getting the absolute value by itself. So let's add that 15 to move it over. So negative 5, absolute value of 5x. If I add 15, I'm going to get positive 10. And then I divide by the negative 5 on the outside. So absolute value of 5x equals, if I divide by negative 5, I'm going to have negative 2. But hopefully you're paying attention. Before you jump into writing your two equations, do you notice that we have absolute value equals a negative? So that means I'm going to write no solution. Okay? And then number 12, we're actually going to cross that one off because we're not going to do that type in Algebra 1. And that's like the rest of the pages, so we're not going to do those. Okay, so there is section 5.2.